Hello student, welcome back to Mr. Lee Technology Channel. This video is about the structural engineering project, the water tower. And let's begin. Over the next few weeks, y'all will be working on the Year 7 structural engineering project, where you'll be designing and building a miniature water tower. This project is not just about building, it's about learning how real engineers design, test, and improve structures. We will go step by step from designing and sketching and construction and testing. Let's get started. So what is structural engineering? Structural engineering is about designing and building safe and stable structures that can withstand different forces. Engineers use scientific principles and creativity to construct everything from bridges and buildings to water tower like the one that you're going to build and design. This project will introduce you to some of these core engineering concepts. So why build a water tower? Water tower plays an important role in storing and distributing water efficiently. They help maintain consistent pressure and ensure a reliable water supply. Throughout this project, you will learn why their design is so important and what makes a water tower strong and stable. For project overview, this is a multi-week project where you will research and sketch your own water tower design. You're going to plan and measure material carefully to avoid waste. And you're going to construct a small-scale water tower using the provided materials. And then you're going to put your tower for a stability and strength test. This is a step-by-step process, and each phase will teach you a new skill in engineering and problem solving. For the assessment breakdown, your final project will be graded based on the 3 or 4 key areas: the design sketch, your ability to plan and visualize your design, which is the water tower; material efficiency, how well you use the material without waste; construction accuracy, quality of your build, which is the miniature water tower; and then the final testing performance, how well your water tower withstand the testing. This is a group project. You work in a team throughout the project. This means that you're going to brainstorming together to design a water tower, dividing responsibility to build efficiently, to help each other troubleshoot problems during the constructions. Material going to provide by the school, you'll be using this. For example, we will provide you with the 5 by 5 mm radiator pine sticks. Total will be about approximately 5 meters. All the basic hand tools, such as the saw, rulers, clamps, and glue. And then a backboard to assist with the stability during the constructions. For the key project constraints, every tower must follow the following parameters. It must hold a 100 by 100 millimeter cylindrical tank. Height must be between 200 mm to 297 mm. Material must be used wisely and efficiently. Planning your design carefully will help meet these requirements. For the structural integrity, as you know, the first thing your water tower will need to be able to uphold the water tank on top. So you're going to ensure a stable water tower to have the safety in place and also need to prevent collapse. The tower should stand upright and remain secure under the weight of the water tank. The load bearing, your tower must be designed to bear the weight of the water tank without blocking it or falling. This involves considering the tank's weight and how it is distributed on the structure. And the structural strength, referring to the tower's ability to withstand the applying force without breaking or collapsing. And this is essential for ensuring safety and longevity. Of course, for this project, we will only use a miniature water tower to test on your stability. And then the water tower will then placed under a stress test by a machine. For the strength to weight ratio, this is about the efficient design. So your water tower will have a height that referring to the strength to weight ratio that is considered efficient. It means the structure can support more weights while using minimal material, making it both strong and lightweight. You could minimizing the material. This is by optimizing your design and using material wisely. You can minimize the weight of your water tower while ensuring it can still support the required load. Performance optimization. Achieving a good strength to weight ratio is crucial for a successful water tower. It ensures the structure can withstand the load without being overly bulky or heavy. In terms of force and load, you need to counter the compression force, the tension force, and the strain. More detailed information you can find from your assessment notification worksheets, where we will require you to conduct a research to complete it as part of the folio work. Triangulation, one of the most common structure that you will see in structural engineering. Its strength and stability is the best. Using triangle in the structural design is a common practice, as it significantly enhances the strength and stability of the structure. And triangle are naturally rigid shapes that can distribute force more evenly. Most of the bridges and tower, you find the triangulations, which is the main structure to support the heavy load. And then also, the triangulation help to assist the weight distribution evenly so that the structure will be more sturdy and strong. If you look at the real-world engineering application, you can always find this kind of triangulation from water tower, from the bridges, and even the cranes will have this. So you gotta make sure during the measuring and cutting, you will use a design sketch to determine the exact length of the radiata pine sticks you need. You're gonna measure carefully to ensure the accuracy of your cut. You're gonna use a push and pull saw, right? It depends on what saw that you will be assigned to. Make sure that you use it to cut the sticks, and be sure to use the saw on a secure cutting board. This is to ensure safety and precision. To secure the cutting board, always use it when working with the saw to prevent accident and to ensure your cut are straight and accurate. Assembly panel. You got to secure the stick to the backboard. So once you have cut the sticks, you secure them to the backboard using nails and wood glue. This will create a stable base for your water tower. You may want to use a small clip to provide additional support if needed during the construction. This can help ensure that the pieces are held securely in place. You got to check the strength of all the joint, ensure the nails are hammered in straight. The glue is applied evenly for a sturdy structure. So from this picture, you can see the nail itself is not nailing into the wooden sticks. They are just being nailed to the backboard, but next to the wooden sticks to ensure that the nail will actually assist in the positioning. So be sure do not nail it into the radiata pine sticks. They are meant for securing the sticks during the joining. You're going to reinforce the frame, so each of the panel that your water tower needs a secure base. This is essential for ensuring that the tower is strong and stable. Reinforce the joint. This is required to check all the joints to make sure that they are secure. You may need to add additional nail or glue to reinforce any weak spot. For stability check, make sure your frame is stable before moving on to the final assembly. If you look at the picture on the right here, this is the second final stage where the basic frames is being built. And you can see none of the nail is actually nailing onto the wooden sticks. They are just assist into securely place the sticks during the joining. Final assembly require you to remove each of the panel from the backboard. And then you're going to assemble them using glue. Then you have to do the final stability check to ensure that the water tower has a flat top, allow us to put the water tank on top to check the stability, and has a very stable base to allow it to stand for the pressure test. Quality check. Quality check require you to check the upright stability to ensure that the water tower can stand upright, so that when we're doing the tank stability test, the tank can stay on top. You must also have all the joints securely joined together. When you're ready, you're going to put it onto the test. So be sure, always use tools carefully and responsibly. Follow safety guidance and wear protective gear like safety goggles when necessary. You're going to minimize material waste, and teamwork plus communication is the key to have a successful project done. During the test, you're going to observe and calculate the strength to weight ratio. So the weight measurement require to carefully weight your water tower to check what is the actual weight. You're going to use a scale to get an accurate measurement. The load capacity, we can observe it from the machines, where it will show what is the actual maximum strength that it will stand. While for ratio calculation, you're going to divide the load capacity by the weight of the tower to calculate the strength to weight ratio. And this will tell you how efficient your design is. So during the testing of the water tower, you're going to first carefully place the tank on top to check for the stability. And then you're going to observe how your water tower can bear the load. And if there's any minor adjustment, you can adjust it. Once everything done, the teacher will then apply the stress test on your water tower. Pressure testing procedure, also known as the stress test. We will have the testing machines. You're going to place your water tower on the stress test machine, and the teacher will gradually apply the force, which is the pressure, onto the water tower. And this will come up with a durability test, and you will know how strong and sturdy your water tower can withstand. Of course, sometimes you may fail, sometimes you may succeed. So observing failure and improvement is important. This allows you to identify the weak points, to carefully observe your tower during the testing, to identify any weak points or areas where it fails. Note this area for the future improvement. You're going to analyze design flaws by considering why these weak points exist in your design, and were there any errors in your measurement, your cutting, or construction process. Any potential improvement? This require the team to brainstorm any potential improvement that your design can actually learn from the past, and also learn from the testing, and constantly adding reinforcement or modifying the shape of your tower. Post-test reflection. You could document all the findings and also record what's what works well and what will be the area for improvement. Do take note, sustainability and ethical consideration. Material choice. This have to think about the environmental impact of the material that you use. Consider using sustainable and recycled material whenever possible. Not just for water tower. Whenever you construct things, this should always be the first priority. And you also need to learn how to reduce waste. Try to minimize waste during the construction process. The proper planning and accurate cutting can actually help reduce material waste. It could be the responsible resource users. Considering the ethical implication of your design and construction decision. Are you using resources responsibly in and minimizing any negative environmental impact? The final takeaway and the end of project. As we conclude this project, at the very end of this project, take a moment to reflect on the lessons you have just learned, teamwork, structural engineering principle, and the importance of carefully design and construction. Remember, every project, no matter it's big or small, present valuable opportunity for learning and growth. Thanks for watching. And now we may go into the next step to look at some of the water tower building and procedure.